Session 5, Introduction to Kubernetes. What is Kubernetes? Why do we need it? Terminology, starting with the Kubernetes and Kubernetes and Swarm, Docker Swarm. What is the difference? Kubernetes is a very popular option for managing containers and potentially other things. It is a mature open source project based on learning from internal Google projects, also known as K8s. Interestingly, this numerical 8 is nothing but the number of characters between K and S. Developed by Google and was donated to Cloud Native Computing Foundation. It has extensible, flexible API architecture, which is expressed in object types. It is not necessarily just about containers, but we can use other related resources also, like storage, role-based access control, networking. Can group multiple containers together in a single logical unit for management and deployment purpose. This is the architecture of Kubernetes. Kubernetes control plane or the master is running as API server. The API server stores the data in etcd. The cluster data and state of the cluster is stored in the etcd database, which is distributed database. Controller manager and scheduler, everybody interact with the every component interact with the API server. Kubelet is actually is the agent running on the worker node, which takes care of provisioning and management and launching and terminating the containers based on Docker or other container runtime. It also is responsible through the container runtime and others. It is responsible for managing the images also in the images registry. So if you notice that on the master node we have API server, on the worker node we have agent running. And this is how the traffic works, how the Kubernetes works. The client application sends the request to the load balancer or the public facing IP address. That load balancer or front end will have a service configured. The service actually have this load balancer configured. So the service has this manifest file or the specifications where we have the targets and pods with labels and selectors are configured in the service configuration. So based on the request, it will forward the request to appropriate pod, matching with the label selector like app, SA, front end. So these are the labels configured for these two pods. So therefore the request will go to either this pod or this pod. So that means the service object actually do a primitive load balancing also, forwarding the traffic on the pods running on different hosts. So we'll take care of the initial load balancing. More on this architecture documentation is available at this location, but this is the screenshot taken from that URL. Kubernetes master, Kube API server, etcd, Kube scheduler, manager, controller manager. And this is what the two-headed arrow I was talking about, where on the worker node we have kubelet and kube proxy running. Kube proxy is for network connectivity. Pods have containers inside them which are managed on the nodes. So we have multiple worker nodes. To be honest, we also configure multiple API servers for the high availability, for the purpose of availability and fault tolerance. Kubernetes installation considerations. Download Kubernetes from upstream repositories or VM or physical server. Consider the criteria to consider while evaluating a Kubernetes solution. This is not from me to you, this is should be from you. You should look at these criteria in your environment with your user, that whether it is applicable for you or not. For example, high availability. The solution which you are providing for your customer, does your Kubernetes solution install clusters that are highly available? Meaning the replication of like at least two master nodes and more than three worker nodes, so that if one master is down, we have another master available. If one worker node is down, we still have the other worker nodes available. With replication of the underlying metadata for recovery against failures. Kubernetes community delivers a major upgrade every 3-4 months. So what is your upgrade strategy? What is your Kubernetes upgrade strategy? What downtime will upgrade require, and is that acceptable for the business? You need to answer this question also. Support for hybrid. Does your Kubernetes solution equally support the private data center and public cloud endpoint that your business needs to deliver Kubernetes on? The client may prefer support for hybrid, the public cloud and the private cloud. Federation support. Does your Kubernetes solution support installation of federated clusters that can grow across private and public clouds for robustness of infrastructure and dynamic stability? You need to plan and take a call on this also. These are the considerations. And finally, enterprise ready features. What additional enterprise readiness features does your ops team need to run Kubernetes at scale for large scale of users? Are they supported for your Kubernetes solution of choice? For example, single sign-on, role-based access control, isolated networking, persistent storage. All these things are required. So do you have that support in your Kubernetes cluster for these features which are needed? Then let's talk about what all we need to deploy on the master node. Master node or the control plane node has one component called API server. API server provides Kubernetes API using JSON or YML over HTTP. The states of API objects are stored into the etcd database. We have scheduler also running. It is a program on the master node which performs scheduling tasks like launching containers in worker nodes based on the availability of resources. Controller manager. Main job of controller manager is to monitor replication controllers and create pods to maintain the desired state. And etcd, as I said, is a key value pair database. It stores configuration data of cluster and cluster state. We installed all these components when we configured that kube init. It deployed all these pods, and these were the basic pods running when I deployed the cluster for the first time. Then the command line utility kubectl. It is command line utility which connect to the API server on port number 6443, used for administration, and it is used by administrators to create pods, services, deployments, replica sets, resources, all storage, everything. On the worker node, we have Kubernetes. Kubernetes is an agent which run on every worker node. It connects to the Docker or other container runtime and takes care of creating, starting, and deleting containers. We also have kube proxy, which routes the traffic to the appropriate container based on the IP address and port numbers. In other words, we can say that it is used for port translation. And pod, that can be defined as multi-tier or group of containers that are deployed on a single worker node or Docker host or podman host. There was a solution from Docker that was Docker Swarm. Docker Swarm was nothing but multiple physical hosts and containers were deployed, number of replicas were created, and the overlay network was configured so that pod or running on, container running on this one host can readily communicate without any problem can communicate with the containers running on another pod or another host. Docker Swarm is also physical cluster of physical machines. So why we are not using Docker Swarm? Why we have to come out with a Kubernetes cluster, which is also a cluster? Let's understand the difference from different parameters. Kubernetes focus on open source and modular orchestration, offering an efficient container orchestration solution for high demand applications with complex configurations, whereas Swarm emphasizes ease of use, making it most suitable for simple applications that are quick to deploy and easy to manage. It features an easy dashboard and helps you to deploy containerized application on a cluster and manage cluster resources. View and error log and information on the state of the cluster resources for efficient troubleshooting. All these are all the features of Kubernetes. Whereas Swarm does not come with web UI out of the box. However, there are third-party tools available which offers similar functionality. But we'll look at from other perspective also. For example, application definition and deployment. What is the difference between the two? A Kubernetes deployment involves describing declarative update. We will discuss this. We have a complex and comprehensive session on this deployment only. Don't worry. To application state, while with the updating Kubernetes pods and replica sets. With Kubernetes deployment, you can define all aspects on application lifecycle, including the number of pods, images to use, how pods should be updated. All these you define in a single file, and that is deployment. In Docker Swarm, you deploy and define application using predefined Docker Swarm files to declare the desired state. To deploy the app, you just need to copy the YML file at a root level. This file, also known as Docker Compose file, allows you to leverage its multiple node machine capabilities, thereby allowing you to run containers and services on multiple machines and any number of networks. Scalability perspective of both the solutions. Kubernetes supports auto-scaling on both at cluster level through cluster auto-scaling, at pod level using horizontal pod autoscaler. We will be looking at and we'll be working with this also, horizontal pod autoscaler. At its core, Kubernetes acts as an all-inclusive network for distributed nodes and providing strong guarantees in terms of unified API sets and cluster states. Scaling in Kubernetes fundamentally involves creating new pods and scheduling it to nodes with available resources, whereas Docker Swarm deploy containers quicker. This gives the orchestration tool faster reaction times that allows for on-demand scaling. Scaling a Docker application to handle high traffic involves replicating the number of connections to the application. You can therefore easily scale your application up and down for even higher availability. Networking comparative study of the two. Kubernetes create a flat peer-to-peer connection between pods and node agents for efficient inter-cluster networking. This connection includes network policies that regulate communication between pod while assigning distinct IP addresses to each of them. To define subnet, Kubernetes networking and model require two classless inter-domain routers CIDRs, one for node IP addressing and other for services. Whereas Docker Swarm create two types of network for every node that joins a swarm. One network type outlines overlay of all the services within the network, and second, the other create a host only bridge for all the containers. Monitoring. Kubernetes offer multiple native logging and monitoring solutions for deployed services within the cluster. These solutions monitor application performance by inspecting services, pods, and containers, observing the behavior of an entire cluster itself. But problem with Docker Swarm is this major. Docker Swarm does not offer monitoring solution out of box. As a result, you have to rely on third-party application to support monitoring of Docker Swarm. Typically, monitoring a Docker Swarm is considered to be more complex due to its sheer volume of cross-node objects and services relative to K8's cluster. This was a comparative study points between Kubernetes and Docker. That's all for this session.